Assalamualaikum and welcome guys. Title: Nuclear Chemistry. Today I want to talk about the concept of nuclear chemistry. Nuclear chemistry is the study of reaction that involve change in nuclear structure. The section on atom, molecules and ions introduce the basic idea of nuclear structure, that the nucleus of an atom is composed of protons and neutrons. Recall that the number of protons in the nucleus is called the atomic number Z of the element, and the sum of the number of protons and the number of neutrons is the mass number A. Atoms with the same atomic number but different mass number are isotopes of the same element. When referring to a single type of nucleus, we often use the term nuclide and identify it by the notation A over ZX. When X is the symbol for the element, A is the mass number and Z is the...
I am Abhinesh. Today I want to present about the type of radiation. There are three types of radiation are alpha particle, beta particle and gamma ray. The first one is alpha particle. It's a helium nucleus, 2 protons and 2 neutrons. It has a large mass compared to other ionizing radiation and a strong positive charge. The second is beta particle. It's a fast moving electron. It has a very small mass and a negative charge. The third one is gamma ray. It's a high energy electromagnetic wave. Gamma rays are caused by changes within the nucleus. They are part of electromagnetic spectrum and so travel at the speed of light. They have no mass and no charge. Okay, the second part is properties of radiation. The first one is alpha. Most alpha radiation is not able to penetrate human skin. Alpha emitting materials can be harmful to humans if the materials are inhaled, swallowed or absorbed to open wounds. The third one is a variety of instruments has been designed to measure alpha radiation. Special training in the use of these instruments is essential for making accurate measurements. Examples of some alpha emitters are radium, radon, uranium and thorium. The second one is beta radiation. Beta radiation may travel several feet in air and is moderately penetrating. Beta radiation can penetrate human skin to germinal layer where new skin cells are reproduced. If high levels of beta emitting contaminants are allowed to remain on the skin for a prolonged period of time, they may cause skin injury. Beta emitting contaminants may be harmful if deposited internally. Example of some pure beta emitters: strontium 90, carbon 14, tritium and sulfur 35. Gamma radiation. Gamma radiation or X-rays are able to travel many feet in air and many inches in human tissue. They readily penetrate most materials and are sometimes called penetrating radiation. X-rays are like gamma rays. X-rays too are penetrating radiation. See radioactive sources and machines that emit gamma radiation and X-rays respectively constitute mainly an external hazard to humans. Gamma radiation and X-rays are electromagnetic radiation like visible light, radio waves and ultraviolet light. These electromagnetic radiation differ only in the amount of energy they emit. Gamma rays and X-rays are the most energetic. This example of some gamma emitters: iodine 131, cesium 137, cobalt 60, radium 226 and technetium 99M.
Now we move on about nuclear transmutation. This is a conversion of one element of isotope into another. And for the history, this is the fact of particle accelerator. Moving from that, we are going to talk about transuranium element. It was one of a stable nuclear elements. Okay, for some mini fact, We also must know this element was too expensive, even can reach 60 million.
Is nuclear fission. Nuclear fission. Nuclear fission is a process in which a heavy nucleus with mass number greater than 200 divides or splits to form smaller nuclei of intermediate mass and one or more neutrons. The fission of heavy elements is an exothermic reaction, and huge amounts of energy are released in the process. Nuclear fission occurs with heavier elements where the electromagnetic force pushing the nucleus apart dominates the strong nuclear force holding it together. In order to initiate most fission reactions, an atom is bombarded by a neutron to produce an unstable isotope which undergoes fission. There are two types of nuclear fission, and the first one is known as subcritical mass, which makes the chain reaction stop because neutrons are lost from the mass without causing fission. And secondly, it is known as supercritical mass, which makes the chain reaction proceed continuously. For a chain reaction to occur, enough uranium must be present in the sample without causing fission. Otherwise, many of the neutrons will escape from the sample, thus the chain reaction will not occur.
Physicists were exploring at the time. By thinking that way, Meitner realized that when a neutron hits a uranium nucleus, it could make the nucleus sort of stretch out and then pinch together in the middle and then split in two, like one drop of water splitting into two smaller droplets. She and Frisch calculated that the larger uranium atom would split into two lighter elements, barium and krypton, plus a whole bunch of neutrons and a whole lot of energy. In other words, she figured out nuclear fission.
The next type of nuclear is nuclear fusion. It is where energy is produced by smashing together like atoms. Fusion is the process by which the sun and the other stars generate light and heat. It is most easily achieved on Earth by combining two isotopes of hydrogen, that is deuterium and tritium. What is fusion power? In the picture we can see that as deuterium and tritium fuse together, their component parts are recombined into a helium atom and a fast neutron. As the two heavy isotopes are reassembled into a helium atom, you have extra mass left over, which is converted into the kinetic energy of the neutron. So these are the difference between nuclear fission and nuclear fusion. Nuclear fission is the splitting of a large atom into two or more smaller ones, while fusion is the fusing of two or more like the atoms into a larger one. Nuclear fission natural occurrence is in the process of closed natural fission reactors, while fusion occurs in stars such as the sun. The conditions for nuclear fission to happen is to have a critical mass of the substance and high-speed neutrons, while nuclear fusion needs high density and high temperature environment. In nuclear fission, it only needs little energy to split two atoms in a fission reaction, while in fusion, it needs extremely high energy to bring two or more protons close enough that nuclear forces overcome their electrostatic repulsion.
Okay, this is Aizudin, so we were going to talk about nuclear reaction comparisons first. Okay, first is atom nucleus. Nuclear reaction involve interchange in atom nucleus usually produce different element, while the chemical reaction only involve rearrangement of the electron, guys. Okay, the second one is isotope different. Different isotope of an element normally behave similarity in chemical reaction. The nuclear chemistry of different isotope may vary greatly from each other. Is temperature and catalyst. The rate of chemical reaction influenced by temperature and catalyst, while rate of nuclear unaffected at all. Next is energy. energy change accompanying nuclear reaction are much larger than the energy change from the chemical reactions, guys. For bonus facts, for nuclear facts, we get the nuclear reaction independent of the chemical form of the element and mass, not strictly conserved because some of the mass converted to energy, guys.
Do you know about the importance of nuclear? So, nuclear energy has various interests. Today, I will tell you 5 nuclear interests. So, the first one, nuclear technology plays an important role in medicine. Example like sterilized medical materials, and then diagnostic tools for detecting and diagnosing various types of disease, and then helps doctor determine if the thyroid gland is functioning normally. The second one, non-destructive testing techniques of nuclear gauges and potential testing techniques. Example, used to detect cracks in metal testing. And then the mixing of radioactive material into a piping system that drain petroleum or water allow underground flow rates and leaks to be detected. And solve problem in engineering plants. Number 3, nuclear technology also contributes to the military field. Nuclear technology is often exploited to make nuclear weapons, for example, atomic bomb, nuclear bomb, and nuclear missile. In addition, nuclear submarine could also be built. The first nuclear submarine was launched by Russia in 1954. Next, nuclear technology is important in developing and advancing the field of education. Example like science and technology discipline such as chemistry, genetics, physics, biology, biochemistry, engineering, and so on are highly depends on nuclear technology. Next, research and development in this field require nuclear technology. And then for the last one, natural gas explorers. We all realize that natural gas is trapped in rocks, and use of bomb and nuclear technology can actually help rocks become more permeable by allowing liquid or gases to pass through them. Nuclear impact on the environment. So guys, this is the introduction. Nuclear power is not a climate solution. It may produce low carbon energy, but this energy poses many risks and disadvantages. Solar power, wind power, geothermal power, hybrid and electric cars, as well as aggressive energy efficiency are safer, cheaper, faster, more secure, and less wasteful climate solution than nuclear power. The first nuclear impact is low-level radiation. Nuclear power plants always emit low level of radiation to the environment. Long-term exposure to low-dose radiation has been shown to damage DNA. The low level of radiation, vulnerability to wildlife, plants, and the ozone layer are not understood, like you see in the picture. And then next, we go into the various diseases. The nuclear material release will cause humans to be born with various diseases, such as genetic mutation and cancer. Nuclear testing will cause the ozone layer to be partially destroyed, and it causes humans to be exposed to sunlight. Forever, humans will suffer from skin disease. So the last one, lost soil fertility. Affected area will lose soil fertility. This will result in loss of food and protein resources. This is because the released nuclear material will damage the soil fertility of the area. Lack of food resource will also affect the economic field of the area because meet food needs. So that's all the nuclear impact on the environment. Nuclear energy is very dangerous to life on Earth. If nuclear is released from the air, all life will be destroyed.